Imagine a time before Earth, before the Sun, before even our solar system. The universe was a vast dark expanse filled with swirling clouds of dust and gas. These clouds were remnants of ancient stars, exploded and scattered across the cosmos. Gravity, the silent conductor of this cosmic orchestra, tugged at these particles, drawing them together in a slow, mesmerizing dance. Billions of years ago, one such cloud, a swirling nebula, became the birthplace of our solar system. This nebula, a chaotic yet beautiful mess of cosmic debris, held within it the seeds of Earth and all the planets that orbit our sun. It was a crucible of creation, a place where gravity ignited the fires of a new star and set in motion the events that would shape our world. The nebula was not a place of stillness. It churned and pulsed with energy, a cosmic storm brewing in the vastness of space. Within its depths, particles collided, stuck together, and grew, their gravitational pull increasing with their size. Over eons, this process, a slow and steady accumulation, formed the building blocks of planets, planetesimals, that continue to draw in the surrounding matter. As the cloud contracted, it began to spin faster and faster, like a figure skater drawing in their arms. This spinning motion flattened the cloud into a disk with a growing concentration of matter at its center. The center, under immense pressure, ignited, giving birth to our sun, a blazing star that bathed the surrounding disk in light and heat. Farther out from the sun, in the cooler regions of the disk, the dance of dust and gas continued. Here, the remnants of the nebula coalesced into smaller clumps, drawn together by gravity. These clumps, the seeds of planets, collided, smashed together, and gradually grew larger and larger. Each collision released heat, melting the nascent worlds and forging them into spheres under their own gravity. One of these nascent worlds, a fiery ball of molten rock and metal, would eventually become our Earth. Bombarded by asteroids and comets, the young Earth glowed with the heat of its formation. This period, known as the Hadean Eon, was a time of intense heat, volcanic activity, and constant bombardment from space. It was a chaotic and violent birth, but from this fiery crucible, Earth would emerge transformed. Imagine Earth as an apple. When you cut the apple open, you see different layers: the skin, the flesh, and the core. Earth, too, has layers, each with its unique composition and properties. The outermost layer, the Earth's crust, is like the apple's skin. It's the thinnest layer. This is where we live, build our cities, and grow our food. Beneath the crust lies the mantle, the thickest layer, akin to the fleshy part of the apple. The mantle is hot and dense, and although solid, it behaves like a very viscous fluid over very long periods. Deep within the Earth, like the apple's core, lies the Earth's core. This core, composed mostly of iron and nickel, is divided into two parts: the outer core, which is liquid, and the inner core, which is solid due to immense pressure. The Earth's core plays a vital role in our planet's magnetic field, a protective shield that deflects harmful radiation from the sun. Now, imagine the Earth's crust as a giant jigsaw puzzle, broken into pieces called tectonic plates. These plates, far from being static, are in constant motion, albeit extremely slow, drifting atop the semi-fluid mantle. This movement, driven by heat from the Earth's interior, is what we call plate tectonics. The interactions between these plates shape the Earth's surface, creating mountains, valleys, and ocean basins. Where plates collide, they buckle and fold, pushing up mountain ranges like the Himalayas. Where they pull apart, magma rises from the mantle, creating new crust and forming features like the Mid-Atlantic Ridge. Plate tectonics are a fundamental concept in understanding our planet. They explain not only the distribution of continents and oceans, but also the occurrence of earthquakes, volcanoes, and the formation of many of Earth's most dramatic landscapes. Section 5. Volcanoes, Earth's fiery breath. Volcanoes, often perceived as destructive forces, are actually windows into the Earth's fiery heart. They are vents in the Earth's crust where molten rock, ash, and gases escape from the mantle. This molten rock, called magma when it's underground and lava when it erupts, is a powerful reminder of the intense heat and pressure that exists within our planet. Volcanoes form in various ways, often near the boundaries of tectonic plates. When plates collide or pull apart, they create pathways for magma to rise to the surface. The type of eruption a volcano produces depends on the composition of the magma. Some eruptions are explosive, sending plumes of ash and gas high into the atmosphere, while others are effusive, with lava flowing slowly like molten rivers. While volcanic eruptions can be destructive, they also play a vital role in shaping the Earth's surface and atmosphere. Volcanic ash, rich in nutrients, can fertilize the soil, and volcanic gases have contributed to the formation of our atmosphere over billions of years. Section 6. Earthquakes. When the Earth trembles, imagine the Earth's crust as a giant puzzle, with each piece representing a tectonic plate. When these plates move, they grind against each other, creating immense pressure along their boundaries. Sometimes, the pressure builds up until the rocks can no longer withstand it, and they suddenly break or slip, releasing a tremendous amount of energy in the form of seismic waves. We experience this sudden release of energy as an earthquake. The point where the earthquake originates within the Earth is called the focus, and the point directly above it on the surface is called the epicenter. Earthquakes can vary in intensity, from barely perceptible tremors to catastrophic events that can level cities and trigger tsunamis. Earthquakes, although often destructive, are a testament to the dynamic nature of our planet. They are a reminder that the Earth is constantly changing, reshaping its surface through the slow, relentless movement of its tectonic plates. Section 7. Shaping the landscape, mountains and oceans. The Earth's surface, far from being static, is a dynamic canvas shaped by the interplay of plate tectonics, erosion and weathering. Mountains, the most awe-inspiring geological formations, are products of this dynamic interplay, formed over millions of years. Most mountains rise where tectonic plates collide, forcing the land to buckle, fold, and uplift. The Himalayas, the highest mountain range on Earth, are a prime example of mountain formation due to plate collision. These majestic peaks continue to rise even today as the Indian plate pushes relentlessly into the Eurasian plate. In contrast to mountains, ocean basins form where tectonic plates pull apart or diverge. As plates diverge, magma rises from the mantle to fill the gap, creating new crust and widening the ocean floor. The Mid-Atlantic Ridge, a vast underwater mountain range, is a testament to this process. Here, the North American and Eurasian plates are slowly pulling apart, allowing magma to well up and create new ocean floor. The Earth's surface is a tapestry woven from the threads of geological processes. Understanding these processes allows us to appreciate the beauty and complexity of our planet's ever-changing landscapes. Section 8. A Journey Through Time. From its fiery birth to the present day, Earth has undergone a remarkable transformation. Over billions of years, it has evolved from a molten ball of rock into a vibrant, life-sustaining planet. The journey has been long and eventful, marked by periods of intense heat, volcanic activity, and dramatic shifts in climate. Yet, through it all, Earth has endured, its story etched into its rocks, oceans, and continents. As we delve deeper into Earth's history, we uncover a fascinating tale of geological processes, from the slow, relentless movement of tectonic plates to the explosive power of volcanoes and earthquakes. These processes have not only shaped the Earth's surface, but also influenced the evolution of life itself. Understanding Earth's past provides us with a deeper appreciation for the present and helps us prepare for the future. By studying the planet's history, we can better understand the forces that shape our world and the challenges we face as stewards of this remarkable planet. Section 9. Keep exploring. This journey through Earth's formation is just the beginning. There's so much more to discover about our dynamic planet, from the intricate workings of its climate system to the incredible diversity of life that it supports. So, keep exploring, keep asking questions, and keep marveling at the wonders of the world around us. What influences our weather patterns? How do oceans contribute to regulating our climate? These questions and more await your curious minds. Delve deeper into the fascinating world of geography, and you'll discover a tapestry of interconnected systems that make Earth the unique and vibrant planet we call home.
Like, share, subscribe, and press the bell icon for more updates. Keep learning, keep vibing.